Okay, now we said that measurements had significant figures yesterday, but there are ways that we can get numbers that aren't measurements. Say, what? You get numbers that aren't measurements? And because they're, the way we get them doesn't have any measurement, the way we get them doesn't have any estimated numbers. That the numbers are all exact. Okay? So what do you mean exact? Well, counted numbers. If I count something, I'm not estimating the last one. Counted numbers like, there are 12 eggs in a dozen eggs. Anybody going to go to the store and buy 11.9 eggs? How about 12.1 eggs? No, you get whole eggs every time, right? So it's really 12.0000000, and the zeros go on forever, right? It's an exact number. It doesn't have an estimate in it. That's why we don't talk about it with Sig Figs. Anybody want to be in a room with 31.9 students? That'd be kind of messy, wouldn't it? We're in agreement, right, that it's whole students all the time. Okay? Counted numbers are exact. The second place you can get them is definitions. Some numbers are definitions. When we use the metric system, we'll learn that 1 meter is 100 centimeters, because the definition of a centimeter is 1/100th of a meter. Okay? Or in the English system, 16 ounces is 1 pound. It is. It's not going to be 16.1. It's not going to be 15.9. It's going to be exactly 16 every time, because that's the definition of a pound. Okay? So since these two things don't have any estimated numbers, we can write them as, I can write that as 16.00000 forever. Right? So that would be unlimited significant figures. All those zeros would be meaningful. It's exactly 0. Everybody right with that? Make sense? Okay. Just want to let you know that not every number has significant figures. The math ones upstairs don't have significant figures. They're all just defining stuff. Their 7 is a definition. It's perfect. And so today, first thing we learn to do is add and subtract. And the whole basis behind where we round off when we add and subtract is that we know that the last sig fig in a measurement is estimated. We're not sure of it. Right? The last sig fig is always an estimated number. So that's why it was important that you learn how to count them and figure out where the sig figs were in numbers last night. Right? Because you're finding the estimate. So your answer, when you add or subtract, can't be better than your worst estimate. I can't get a better answer by adding numbers than the measurements I started off with. It's hard to word what you have to do. It's actually really, it's pretty easy to do. Okay? It's just hard to word. You round it to the biggest estimate of the measurements in the problem, which is going to be furthest left. Furthest to the left is going to be the biggest estimates, because the numbers get bigger as you go further left. 8, 60, 300. if I don't know where I start very well, even if I have a really accurate tape measure, I won't know how far I ended up away, because I don't know where I started. And we'll see what it looks like. It makes sense if you picture what the numbers are really describing. But first, let's get the mechanics of it, and then we'll talk about what it means. Okay. If I wanted to add those two numbers, what's the first thing you would have to do? First, that's line of decimal places, right? You're adding line of decimal places. And then you add, right? We're going to do all that. We're going to do the problem just the way it's written. Now, once you get the answer to this point, then you have to decide how many significant figures can I have in my answer. What can I do there? So the mechanics is to find the estimated numbers in the problem. So in 27.93, what is the estimated digit? The 3 at the end, right? And in 6.4, what's the estimated digit? The 4. Whatever the last sig fig is, we're not sure of it. So that tells us these two things were measured on different devices. Right? You tell me because no, on the decimal basis. Okay? So the estimated numbers are the 3 and the 4. Which one of those is in the biggest place? The 4. Which one's furthest to the left? The 4. So that's where I got to round it off. It's in the 10th place. So 34.3. So I line it up, find the estimated, and whichever one is furthest to the left, that's where I round it off. Why? Well, let's talk about it in terms of meaning. Okay. The top number of this 3 is estimated, right? What comes after that 3? What would this digit be? I have no idea, do I? I know that 3 is estimated, so there's probably something there, but I have no idea what it is. What about this, right here? You have any idea what's behind that 4? So, what does 3 plus I don't know equal? I don't know. That's why we can't keep that 3 there. We don't know it's a 3. Because 3 plus I don't know doesn't equal 3. 3 plus I don't know equals I don't know. Okay. Everybody comfortable with that? Okay. And that means this 3 is the estimated number. Because if I add 27.93 to something that's about 6.4 away, the best I'm going to be able to say is it's about 34.3 of it. I can't go any further than that 4 because that's the, I'm not even sure that's a 4. It might be a 3, it might be a 5. Which would make my 34.3 either a 2.2 or a 0.4. Makes sense? Because I'm sure I'm adding a 9 to it. Because I'm absolutely sure that's 9. 9 plus something close to 4 equals something close to 13. Doesn't it? So that's the meaning of this adding black words. It's not some random set of rules. It really means something. It leads to some bizarre results, which you won't be pleased with. I'll give you a few examples of them later. So 4.8 grams plus 6.8765 grams. 5, 6, 7, 6. Grams plus grams. So my calculator gives me 11.6765 grams. Sometimes your calculator can give you more significant figures, give you more digits than are justified. Okay? So, estimated numbers. The estimated number in 4.8 is 8. And in 6.8765, 5. Which one of those is furthest to the left? 8. So that's where I'm going to have to round it off. So it's 11.7. Because behind that 6, there's a 7, I round it. See why I had wanted to practice counting sig figs last night and rounding off to a certain number? Now I'm telling you to round off to a certain place. Okay. $520 meters minus 94.98 meters. What's plus? Ooh, that's easier. I'll just subtraction later. 8, 9, 4, 6, 14.9. Okay, in 94.98, what's the last sig fig? 8. In 520, what's the last sig fig? 2. 0 is not a sig fig. That's why we had to make sure which zeros counted. I knew this was coming. So I'm going to round it off here. So the 6, I keep the 1 because there's a 4 behind it. Is my answer 61? Now I got to put the placeholder in 610. Okay with that? So you see, you got to watch out for those zeros. But do they count or don't they? .0045 liters plus 2.113 liters. Calculator's going to give me 2.1175 liters. Check out the last sig fig. The last sig fig in .0045 is 5. And then 2.113, it's the 3. Which one of those is furthest to the left? If I'm not sure that this is a 3, I have no idea what I'm adding to 5. 5 plus I have no idea equals I have no idea. It's not even an estimate. I have no idea. Right? Okay, this is the one that drives people crazy. Because I say, hey, 500 minus 126 is 400. Looks really wrong, doesn't it?
Zeros don't count.
But it's the right answer. Because, well, what? I do 500 minus 126. My calculator gives me 374. What's the last sig fig in 500? 5. Last sig fig in 126? 6. So I have to round off where the 5 is. That's 400. It looks just wrong, but it's right. Because what if I look, okay, if you look out across the field, it looks like your friend's standing about 2 football fields away. They're about 500 meters away. And they walked 126 meters closer to you. How far away are they now? Can you say 374? Because you don't really know where they started, right? All you do is they're about 500 away. If they walk 126 closer, they're about 400 away now. So I didn't really know well where they started. I can't say very well where they ended up. It's all about that number being an estimate. It makes sense, doesn't it? Okay, so that's why 7,200 plus 47 is 7,200. Because 7,200 is in the hundreds place. This is someplace between 7,100 and 7,300. If I add 47 to that, I'm still someplace between 7,100 and 7,300 as far as I know. Make sense? So I'm big enough to change it. So. Now I have bad news. Multiplication division has a completely different set of rules. that wasn't too bad, but that was the hard one. Good news is, it is much simpler. And we will be multiplying and dividing more often than we'll be adding and subtracting. So our real problem is going to be remembering to add and subtract. That once you do this, you want to do it for everything because it's easier. But it doesn't work for adding and subtracting. You got to remember which set of rules to apply where. And here's the rule. The same number of sig figs in the answer as the least in the question. So if you had three numbers that you multiplied, and one had 2 sig figs, one had 4 sig figs, and the third one had 5 sig figs, 2, 4, and 5, 2 is the smallest, you round it off to 2. This is why I had you count the number of sig figs times last night. Because you have to do it a lot. It's got to be something that you can do pretty fast. So, 3.6 times 650. Push those buttons on your calculator, gives you 2350.8. Notice I did not line up the decimal point this time. You don't have to line up decimal points to do multiplication. Right? So that tells you it's not about places. That's a reminder that you need to worry about places when you do adding. You just got to line up the decimal point. Manage how they line up. Okay, how many sig figs in 3.6? 2. How many in 653? 3. Which of those numbers is smaller? 2. 2 is smaller than 3. The answer can only have 2 sig figs. And the second sig fig is the 3. On that 3, there's a 5. Round it up. Put in my placeholders. I get 2,400. Do anything by easier? No lining up, just counting and then rounding. Count, count, round. And the same rules for division. Whichever one has the smallest number, that's what you do. So 4.5 divided by 6.245 equals, with my calculator, 0.720576461. Your calculator can give you more digits than are justified by the original measurements. So, how many sig figs in 4.5? 2. How many in 6.245? 4. So how many my answer? 2. First one, second one, 72.72. I think 0.72 is my answer, 0.72. What if I multiply those numbers instead? My calculator gives me 28.1025. Well, how many answers how many sig figs can my answer have? It's the same numbers, so it's still 2 and 5, 2 and 4, so the smallest is still 2. So the answer is 20. .8764 times 0.043 gives me 0.4246852. How many sig figs in 9.8764? How many in 0.043? 2. The 0 in front doesn't count, so my answer can only have 2. Second one's at 2, so behind that 2, there's a 4, so 0.4. Extra super hard. So I taught you the hard one first because this one you're going to want to do too often. So the hard part is remembering to do adding and subtracting. takes an extra step if you actually have to line pieces up. Make sense? Okay. So hopefully, your homework will make sense. Hey, your homework. 36 to 41, 45 to 47. Hey, that looks like 36 to 37. Maybe you could practice some of these and make sure you know what you're doing before you leave. 5 minutes.